In your grandmother's backyard, there is almost certainly a tree with lacy white flowers and black berries that ripen in autumn, and she has probably told you at some point that it is good for colds, without knowing that this tree has been in the medical records of humanity for 3,600 years, that researchers from 4 European universities have subjected it to randomized clinical trials, and that their results are robust enough for the journal Nutrients to publish them in 2016. The plant is called elderberry. Its scientific name is Sambucus nigra, and the story of how it traveled from the Nile Delta to your grandmother's backyard, passing through Rome, Andalusian Arab medicine, the medieval convents of Galicia, and the Quechua communities of the Andes, is one of the longest and most silent stories of botanical persistence that this channel has ever told. Silent because no one suppressed it with a royal decree or persecuted it with the Inquisition. Elderberry wasn't banned. What happened is more subtle and, in a way, more revealing of how the modern knowledge system works. It was reclassified. It went from being medicine to being folklore. From being the remedy documented by Dioscorides in the 1st century to being what Grandma says. From being part of the official European pharmacopoeia until the 19th century to being something mentioned condescendingly in articles about home remedies on the internet. And while that reclassification was happening, Grandma kept planting the elderberry bush. She kept making the syrup. She kept giving it to her grandchildren with colds. And it turns out she'd been right for 3,600 years. To understand why the elderberry has such a long history, we have to go back to the beginning. And the beginning is in Egypt. The Ebers Papyrus is one of the oldest surviving medical documents in the world. It was discovered in Thebes in 1873 by the German archaeologist Georg Ebers, who purchased it at the antiquities market and donated it to the University of Leipzig, where it is housed today. It dates from around 1550 BCE, although specialists in ancient Egyptian medicine believe it contains even older medical traditions, possibly from the 3rd millennium BCE. The papyrus is 20 meters long and contains approximately 900 medical prescriptions. The elder tree appears in that papyrus. The reference in the Ebers Papyrus is to a plant that specialists identify as Sambucus nigra, or a very closely related species, mentioned for the treatment of burns and skin diseases. It is neither the most detailed nor the most extensive mention in the document, but it is there, on a papyrus that was written when the pyramids of Giza had already stood for 1,000 years. From Egypt, elder traveled across the Mediterranean. Hippocrates, the 5th century BCE Greek physician whose name we still pronounce in the oath taken by medical graduates, mentioned it as a diuretic and laxative. Dioscorides, the Roman military physician of Greek origin who wrote his treatise De Materia Medica in the 1st century CE, the most influential pharmacological text of the next 15 centuries, dedicated an entry to elder, describing the use of its flowers, fruit, bark, and leaves for various indications. Andres Laguna's translation and commentary on that treatise, published in Antwerp in 1555 under the title Pedanius Dioscorides of Anazarbus, was the most widely read medical reference book in Spain during the 16th and 17th centuries, and in it, elder appears with all the authority of classical tradition. Pliny the Elder, in his monumental Natural History of the 1st century, devoted several pages to elderberry, describing how the peasants of the northern provinces of the empire used it for fever, catarrh, and sore throats. What Pliny described was not an exotic practice of barbarian peoples. It was standard medicine in the Roman world. The question that botanical historians have pondered is when elderberry arrived on the Iberian Peninsula. The most likely answer is that it arrived with the Romans, who cultivated it in their villas and carried it as part of their domestic pharmacopoeia to each new province they colonized. Elderberry thrives in temperate and humid climates, meaning that Galicia, Asturias, the Basque Country, the Cantabrian valleys, and the humid valleys of the interior of the peninsula were its natural habitat from the very beginning. But it also adapted to the drier climates of the center and south, always near water, on riverbanks, and along the edges of irrigated orchards. When the Visigoths and later the Arabs arrived on the Iberian Peninsula, elderberry was already a centuries-old part of Iberian folk medicine. Andalusian Arab medicine was no exception. Ibn al-Baytar, the 13th-century naturalist and physician from Malaga, whose Kitab al-Jami is the most comprehensive botanical encyclopedia of the Middle Ages, describes elderberry in detail. Ibn al-Baytar was familiar with elderberry from classical Greco-Roman tradition, Persian medicine, and his own direct observations in Al-Andalus. He describes it as useful for colds, edema, and skin conditions, with recommendations for its use that, when read from the 21st century, are pharmacologically consistent with what modern science has confirmed. In the medieval convents of the Iberian Peninsula and northern Europe, elderberry was a constant presence in the medicinal gardens. The tradition of convent herbalism, which for centuries was the primary institution for transmitting folk medical knowledge, cultivated it systematically. In the Benedictine monasteries of Galicia, the Poor Clare convents of Castile, and the gardens of the Discalced Carmelites, elderberry held a permanent place among the plants used daily. The apothecary nuns, those extraordinary figures whose medical knowledge sustained rural communities for centuries, used it in syrup form for winter colds, as an infusion of its flowers for spring fevers, and as a poultice of its leaves for bruises and contusions. This convent tradition is the bridge between the Roman world and the contemporary world. There was no rupture, there was no forgetting. There was a continuous transmission from convent to convent, from midwife to midwife, from grandmother to granddaughter throughout 15 centuries. When the Spanish arrived in the Americas, they brought elderberry with them. Not intentionally, like someone packing a valuable spice. They brought it because it was part of their home gardens, their travel medicines, their everyday medical knowledge. And in the New World, they discovered something that surprised them. There were already species of Sambucus in the Americas, Sambucus canadensis in the north, Sambucus mexicana in Mexico and Central America, Sambucus peruviana in the Andes. It wasn't exactly the same tree, but it was from the same family, with similar properties, and the indigenous communities of the Americas used it in ways that the Spanish doctors immediately recognized as analogous to their own. In the Andes, Andean elderberry, which the Quechua call rayan or salco, was an integral part of Kalawaya medicine, the itinerant herbal tradition that Kalawaya healers carried from community to community across the mountains. It was used for fevers, high-altitude colds, and the respiratory problems regularly caused by the cold and dampness of the Andean valleys. The Kalawaya combined Andean elderberry with other high-altitude plants in preparations that had their own therapeutic logic, developed over centuries of clinical practice in extreme climatic conditions. In Galicia and Asturias, where the Atlantic humidity and cold winters produce precisely the kind of colds and flu that elderberry treats, the plant has always been a part of the domestic landscape. In the valleys of the Miño, Sil, Navia, and Nalón rivers, elderberry bushes grow wild along the edges of orchards and beside oreos, the traditional Galician and Asturian granaries, where their presence was said to ward off evil spirits, a belief likely stemming from the empirical observation that where elderberry grows, there are fewer insect pests because the tree produces compounds with insecticidal activity that are effective at repelling certain mosquitoes and flies. Elderflowers have a scent like few other plants. The aroma is intense, sweet, slightly fermented, with a hint of honey that never quite becomes honey. In the Atlantic valleys, when the elderberry blooms in May and June, the fragrance wafts along the paths for weeks. Galician and Asturian grandmothers recognize it immediately and know it's time to pick the flowers, the white umbels, as wide as the palm of a hand, for the syrup they'll have ready in November when cold season begins. The process of making elderberry syrup is one of the oldest domestic rituals in Atlantic Europe. The flower umbels are picked in full bloom when the petals are fully open but before they begin to wilt. They are soaked in water with sugar and lemon for 24 hours. The liquid is strained, brought to a boil, and bottled. The resulting syrup has a pale yellow color and an intense floral flavor unlike anything industrially produced. It keeps in the refrigerator for several weeks. In autumn, when the berries ripen and turn black, the process is different and requires more care. Ripe elderberries are edible and medicinal, but raw and unripe berries contain a cyanogenic glycoside called sambunagrin, which can cause nausea, vomiting, and diarrhea if ingested in large quantities. Heat destroys this compound, so the berries must always be cooked before consumption. Cooked berries are used to make the syrup that European folk tradition has employed for centuries specifically for flu-like symptoms, fever, muscle aches, and congestion. This is the product that modern researchers have studied in greater detail. Elderberry appears regularly in official European pharmacopoeias of the 18th and first half of the 19th centuries. The Spanish Pharmacopoeia of 1804 includes elderberry among its recognized medicinal plants. The Royal Spanish Pharmacopoeia of 1845 also lists it. In Great Britain, the first edition of the British Pharmacopoeia of 1864 includes elderberry preparations. In the language of the time, it was a plant with officially recognized uses. And then the 20th century arrived and changed everything. The story of how elderberry went from official pharmacopoeia to grandmother's remedy in the space of about 50 years is really the story of how all herbal medicine was displaced by synthetic pharmacology. It wasn't a conspiracy. It wasn't a decision made in a boardroom. It was the logical outcome of a series of genuinely transformative medical advances that, at the same time, created an incentive system that valued patentability over efficacy. In 1828, Friedrich Wöhler synthesized urea in the laboratory, demonstrating for the first time that organic compounds could be manufactured artificially. This moment ushered in modern synthetic chemistry. Over the following decades, chemists began isolating the active principles of medicinal plants: morphine from opium, quinine from cinchona, atropine from belladonna, aspirin from willow, and then synthesizing and chemically modifying them to make them more potent, more predictable, and, crucially, patentable. Aspirin is the most frequently cited and revealing example. Salicylic acid, the compound that gives rise to aspirin, occurs naturally in willow bark and meadowsweet. For centuries, willow bark tea was the most widely used analgesic and antipyretic in Europe. In 1897, Bayer chemists synthesized acetyl salicylic acid, registered it under the trade name aspirin, and patented it. The result was a more effective, better tolerated, and more easily dosed medication than willow bark tea. It was a real breakthrough. But the business model that this advance created had an unintended consequence. Any treatment that couldn't be patented was excluded from the pharmaceutical investment system. Not because it didn't work, but because it couldn't generate a return on the investment of the clinical trials required for regulatory approval. Elderberry is exactly that kind of case. It can't be patented. Its properties have been in the public domain for 3,600 years. Anyone can grow it, make the syrup, and use it. There's no business model that justifies funding a Phase 3 clinical trial with 100 million euros when, at the end of the process, a competitor can do exactly the same thing with a garden tree. So elderberry wasn't persecuted, it wasn't banned, it wasn't burned, confiscated, or declared diabolical. It was simply ignored by the system that decides what gets researched. It was relegated to folk medicinal plant books, neighborhood herbalists, and grandmother's recipes. And in that relegated space, it survived perfectly well for 100 years, passed down from generation to generation by women who never needed a clinical trial to know what they knew. The last time elderberry appeared in the official Spanish pharmacopoeia was at the beginning of the 20th century. Subsequent editions, as Spanish medicine modernized and adopted the standards of international synthetic pharmacology, removed it from the lists of recognized medicines. Not because there was evidence that it didn't work, but because there was no sufficiently formalized evidence that it did. An impossible standard to meet for a plant whose use was widespread among millions of households across Europe, but whose clinical research had received no funding. The circle was perfect and perverse. Without funding, there were no trials. Without trials, there was no formal evidence. Without formal evidence, there was no official recognition. Without official recognition, there was no funding. And while that circle closed on itself, in the Galician and Asturian valleys, Grandmothers continued to pick the white umbels in May, and in the Andean markets, the Kalawaya continued to sell elderberry, and in the herbalists of Seville and Granada, elderberry syrup continued to be one of the best-selling products on the counter. It was in that parallel space, outside the official system, where the elder tree waited for someone to decide to look at it. The researcher who decided to truly investigate it didn't come to elderberry from a pharmaceutical laboratory. She came from clinical epidemiology with a very specific question. Is there any natural intervention that reduces the duration of the flu in patients who don't want to or can't take synthetic antivirals? In 2016, Dr. Jesse Hawkins, a researcher at Vanderbilt University School of Nursing in the United States, published a meta-analysis in the journal Nutrients of available clinical studies on standardized Sambucus Nigra extract for viral respiratory infections. A meta-analysis is, methodologically speaking, the most robust type of evidence recognized by evidence-based medicine. It doesn't analyze a single study, but rather combines data from several independent trials to obtain a more robust estimate of the effect. Hawkins' analysis combined 4 randomized controlled trials, the most rigorous level of experimental design in medicine, and the results were clear. Elderberry extract reduced the duration of flu-like symptoms by an average of 3.5 days compared to the placebo group. 3.5 days. In an illness that normally lasts between 7 and 10 days, that's reducing the duration by 35 to 50%. Tamiflu, the world's most prescribed synthetic antiviral for influenza, reduces the duration of symptoms by about 1 day when taken within the first 48 hours. Not 2 days, not 3, about 1. This doesn't mean that elderberry is better than Tamiflu in all contexts. Tamiflu has specific indications, especially for high-risk populations where influenza can be fatal and where its ability to reduce serious complications has value beyond the duration of symptoms. Such a comparison would be unfair to both. But in the context of seasonal influenza in healthy adults, the most frequent clinical scenario, the numbers from Hawkins' meta-analysis are striking. The mechanism by which elderberry extract produces this effect was described in more detail in subsequent studies. Researchers at the University of Sydney, Australia, published a mechanism study in the Journal of Functional Foods in 2019 that identified 2 main pathways of action. The first, elderberry flavonoids, especially quercetin and camphorol, inhibit viral neuraminidase, the enzyme that influenza viruses use to release themselves from infected cells and spread to others. Without functional neuraminidase, the virus remains trapped in the cells it has already infected and cannot advance. This is, not coincidentally, exactly the same pathway of action as Tamiflu. Oseltamivir also works by inhibiting neuraminidase. What the Sydney researchers discovered is that elderberry compounds do something similar naturally, although with less potency than the synthetic drug. The second mechanism of action is more complex and, possibly, more important for understanding why elderberry works well in the acute phase of the flu. It modulates the inflammatory response of the immune system. When the body detects a viral infection, it releases a cascade of inflammatory signals called cytokines, which are directly responsible for the most unpleasant flu symptoms: high fever, muscle aches, exhaustion, and congestion. This inflammatory response is necessary to fight the virus, but it is often excessive and causes more damage than the virus itself. Elderberry extracts, according to studies from Sydney and other European groups, modulate this response. They reduce the production of the most aggressive pro-inflammatory cytokines while stimulating the activity of immune system cells that directly attack the virus. Simply put, elderberry not only helps contain the virus, it also reduces the body's overreaction, which is the direct cause of feeling so unwell during the flu. A third study, published by researchers at the Karolinska Institute in Stockholm in Phytomedicine in 2015, analyzed the effect of elderberry syrup on long-haul travelers who developed respiratory infections during or after transcontinental flights, a particularly relevant exposure group given that airplanes are a major vector for respiratory virus transmission. Participants who took elderberry syrup from the onset of symptoms had a significantly shorter illness duration and less severe symptoms than those who took a placebo. The study was smaller than Hawkins' meta-analysis, but its design was rigorous and its results consistent with the overall hypothesis. There is a fourth line of research that deserves specific mention because it connects directly with the Hispanic history of elderberry. Studies on flower extracts, not just berry extracts. Spanish and Latin American medical traditions primarily used the flowers in infusions, flower water, or syrup made with flowers macerated in water and sugar, while Anglo-Saxon pharmacological research has focused mainly on berry extracts for commercial reasons. Flowers have a much shorter season, are more difficult to standardize, and are more complicated to process industrially. However, the phytochemical profile of elderflowers includes compounds that berries do not have in the same proportions: glycosylated flavonoids, chlorogenic acid, and rutin, which have their own anti-inflammatory and antioxidant activity, documented in publications by the Phytotherapy Group of the Spanish National Research Council, CSIC, at the Royal Botanical Garden of Madrid. What this means, in practical terms, is that the Galician grandmother who makes flower syrup in May isn't making something equivalent but inferior to the commercial blackberry supplement. She's making something different with a distinct profile of active compounds, which may have advantages for certain types of symptoms, especially upper respiratory, congestion, and throat issues, while the berry extract has more evidence supporting its use for systemic flu symptoms. It's worth pausing here to acknowledge what science hasn't yet established, because honesty about the limits of the evidence is what makes this story credible and not sensationalist. The 4 clinical trials analyzed in Hawkins' meta-analysis are methodologically sound but of moderate size. They involve a few hundred participants in total, not thousands. The mechanism studies are compelling but rely primarily on cell models and studies in human volunteers under controlled conditions, not large cohorts of flu patients. Elderberry hasn't undergone a full pharmaceutical development program with phase 1, 2, and 3 studies funded by hundreds of millions of euros because, as we've seen, no one has the financial incentive to do so. What we do have is medium to high-quality evidence that consistently points in the same direction. Standardized elderberry extract reduces the duration and intensity of flu symptoms in healthy adults, with an excellent safety profile and a cost that makes it accessible to virtually everyone. That is the state of science. No more, no less. What is striking when this story is viewed in perspective is the consistency between what science has discovered and what medical tradition had observed for 36 centuries. The Ebers Papyrus, Dioscorides, Ibn al-Baytar, the Spanish Pharmacopoeia of 1804, and randomized clinical trials published between 2015 and 2019 are all describing, from completely different languages and methodologies, the same phenomenon: that elderberry has a consistent effect on viral respiratory infections. The grandmother who makes the syrup doesn't know it from any of these sources. She knows it because her grandmother taught it to her, who learned it from hers, in a chain that goes back at least to medieval convents and probably extends, without interruption, to the Roman villas of 1st century Hispania, where the locals learned the remedy from the colonizers who brought it from Egypt. We unearth stories like this every week. If you don't want to miss any, subscribe to the channel. The next one comes from another corner of this same archive and is just as long and just as fascinating. For those who want to use elderberry in a practical way, the most useful information can be found in 3 questions: which part of the plant, how to prepare it, and what precautions to take. Regarding which part, the flowers are used to make infusions and flower syrup, which is the traditional preparation in Spanish and Latin American folk medicine and has evidence supporting its use for upper respiratory symptoms. The ripe, cooked berries are used to make blackberry syrup, which has the strongest clinical evidence supporting its use for systemic flu symptoms. Both parts are useful. They have complementary phytochemical profiles. How to identify the tree. The European elderberry, Sambucus nigra, is a shrub or small tree between 3 and 7 meters tall, with grayish, corky bark in mature specimens, compound leaves with 5 to 7 oval leaflets with serrated edges, white flowers in large, flat umbels between May and July, and very dark black or purple berries that ripen in August and September. It grows along roadsides, riverbanks, orchard edges, and forest borders throughout the Iberian Peninsula, most of temperate Europe and North Africa. In Latin America, there are species of the same genus, Sambucus mexicana in Mexico and Central America, and Sambucus peruviana in the Andes, with similar properties. An important identification warning: in Europe, there is a plant sometimes confused with elderberry, called dwarf elder or buckthorn, whose scientific name is Sambucus ebulus. It is a herbaceous plant shorter than the tree elder, with similar berries, but it is toxic. The main difference lies in its growth habit. Sambucus nigra is a shrub or woody tree. Sambucus ebulus is a herbaceous plant that dies back in winter and resprouts in spring. If you are unsure of the identification, do not use the plant. How to make flower syrup. Collect 15 to 20 fully open flower umbels, shake off any insects, and submerge them in 1 liter of water with the juice of 2 lemons and 400 grams of sugar. Let it macerate for 24 hours in the refrigerator. Strain, bring the liquid to a boil for 3 minutes, bottle it while hot in sterilized jars, and store it in the refrigerator for up to 3 months. The traditional dose for colds is 1 or 2 tablespoons 3 times a day. How to make berry syrup. The berries must be fully ripe and black. Never eat them raw. Cook them with water in a ratio of approximately 200 grams of berries to 300 milliliters of water. Crush them, strain to remove the pits and skin, and mix the resulting liquid with sugar in a 1-to-1 ratio. Bring it to a boil until it thickens slightly and bottle it while hot. The dosage in clinical trials was 15 milliliters 4 times a day, starting at the first flu-like symptom. This amount is equivalent to approximately 1 tablespoon 4 times a day. Contraindications to be aware of. Elderberry modulates the immune system, meaning that people with autoimmune diseases, such as lupus, multiple sclerosis, or rheumatoid arthritis, should consult their doctor before using it, as there is a theoretical possibility that it could stimulate the inflammatory response that is already dysregulated in these conditions. People taking immunosuppressants for any reason, including transplant recipients, should avoid it for the same reason. Pregnant women should abstain, as a precaution, given the lack of sufficient safety data during pregnancy. And for people with allergies to other plants in the Adoxaceae family, although elderberry allergy is uncommon, it is advisable to start with small doses. Elderberry honey, produced in areas where the tree is abundant and beekeepers take advantage of its abundant flowering, has a compound profile that complements that of elderberry syrup and enhances its effects. In Galician tradition, elderberry liqueur, made by macerating the berries in pomace brandy, was the quintessential winter remedy. In Argentina and Chile, where communities of European origin transplanted the tradition along with the tree, elderberry remains a common plant in the orchards of the Andean and southern regions. Commercial black elderberry syrup is now one of the best-selling natural supplements in pharmacies in the United States, Germany, and Great Britain. Brands like Sambucus, which was the first to standardize the berry extract for clinical use in the 1990s, have built a business worth tens of millions of euros annually from the same plant that Galician grandmothers used to grow in their backyards and that no one considered interesting enough to investigate until someone realized that the studies were already waiting in the archives. There's something in this story that goes beyond the elderberry in particular. It demonstrates that folk medical knowledge isn't simply an accumulation of superstitions being dismantled one by modern science. In many cases, it's pre-scientific knowledge accumulated over generations of systematic empirical observation waiting to be formalized by modern methodological tools. The grandmother who makes the syrup is no less right than the epidemiologist who publishes the meta-analysis. They possess the same knowledge expressed in different languages, separated by 3,600 years of history. If this story resonated with something you already knew, or with someone who already knew it, share it. And subscribe to the channel so the next chapter of the archive finds you too. The next time your grandmother offers you a glass of that yellow syrup she's kept in the refrigerator since May, accept it. Not because she's your grandmother, but because she's been right since before Rome existed.